Okay, so last time, I don't know if we were at this place, but at least let's see where it recovered up to. So 16. Okay, so I may have gone further than that. Yeah, I know, but I had to recover things. It didn't recover it. So I'm going to just finish off what we did on problem 16, and then I'll go to problem 17. Okay, so, oh, right. Well, actually, I don't think I'd even started at 17 yet. So let me divide both sides of my inequality by -5. And so I get x is less than or equal to -2, or dividing by 3, x is greater than or equal to -4. Okay. So I have here that x, I just want to graph it, right? Solve it. So x here is greater than -4, or it's less than -2, so that's everything. So x here is less than -2, but it's also, or it could be greater than -4. So it includes everything on the real number line. And that is your answer. Okay, so let me do problem number 17. Solve the absolute value equation. Absolute 3x plus 2 plus 8 is equal to 12. So I want to solve this inequality. So let me subtract 8 from both sides of my equation. So absolute value of 3x plus 2 is equal to 4. Therefore, 3x plus 2 is either equal to -4, or 3x plus 2 is equal to +4. So let me subtract 2 from both sides of my equation. So I get that 3x is equal to -6 divided by 3. So x is equal to -2. Or subtracting 2 from both sides of my equation, I get 3x is equal to 2. Dividing both sides of my equation by 3, I get x is equal to 2/3. So x is equal to -2, x equals 2/3. Both of these satisfy the absolute value equation. 18. Absolute value of 6x plus 8 plus 6 equals 4. Let me subtract 6 from both sides of my equation. So I get the absolute value of 6x plus 8 is equal to -2. Well, you can't have an absolute value being negative. So therefore, There are no solutions, no values of x that will satisfy this equation. So this equation has no solution. Let me do problem number 19. 8k plus 1 in absolute value is less than or equal to 4. Therefore, 8k plus 1 is between positive 4 and negative 4. Let me subtract 1 from each side of my inequality. And so 8k is between negative 5 and positive 3. Divide each side by k to solve for k in the middle. And so k is between negative 5/8 and positive 8/3. So let me graph this. So I have here that k is between negative 5/8 and positive 3/8. So I include negative 5/8 and positive 8/3 and everything in between. Let me do problem number 20. Absolute 7k minus 4 is less than negative 7. Well, again, you can't have that a absolute value is negative, so there's no way that you can have an absolute value less than negative 7, and so this has no solution. The graph, well, the graph looks like nothing, so I'm not including anything on this graph, and that's the solution. So there's just no points on the graph. Problem 21. Absolute x minus 5 plus 1 less than or equal to 4. Okay, let me subtract 1 from both sides of my inequality. So x minus 5 in absolute value is less than or equal to 3. Therefore, x minus 5 is between positive 3 and negative 3. Let me add 5 to each side of my inequality in order to isolate x, solve for x in the middle. 5 minus 3, 2. 5 plus 3, 8. So x is between 2 and 8. It includes both 2 and 8. Since there's an equal sign. Okay. Got scared that it was going to crash again. And so since there's an equal sign in the inequality, then it includes everything between 2 and 8, and it includes both the endpoints 2 and 8. Let me do problem number 22. absolute x minus 3 plus 6 is greater than or equal to 11. Let me subtract 6 from both sides of my inequality. And so I have that the absolute value of x minus 3 is greater than or equal to 5. So therefore, I have that x minus 3 is less than or equal to negative 5, or x minus 3 is greater than or equal to positive 5. Add 3 to both sides of my inequality to put each of these in standard form. So x is less than or equal to negative 2, or x is greater than or equal to positive 8. Okay, so I have here that x is less than or equal to negative 2, greater than or equal to positive 8. So I include negative 2 and everything less than it. I include positive 8 and everything greater than it. And so that is my solution. That's a graph of my solution. Let me do problem number 23. (4k) plus 9 in absolute value minus 5 is greater than negative 3. So let me add 5 to both sides of my inequality. So 4k plus 9 in absolute value is greater than or equal to 2. Okay, so this says that 4k plus 9 is less than or equal to negative 2, or greater than or equal to positive 2. Just greater? Oh, thank you. Thank you. No equal sign. Okay, so this says that 4k plus 9 is less than negative 2 or greater than positive 2. Subtract 9 from both sides of my inequality to isolate k on one side of the inequality. Negative 2 minus 9 is negative 11. 2 minus 9 is negative 7. Divide both sides of your inequality by 4. And so k is less than negative 11 over 4, or k is greater than negative 7 over 4. So let me graph this. So k is less than negative 7 over 4, or bigger than 7 over 4. Okay, so we do not include the endpoints because there's no equal sign, but we do include things that are less than negative 11 over 4, greater than 7 over 4, and that is my graph. that is the solution. Let me do problem number 24. F of x equals 5x minus 1 if x is less than or equal to 0. 1/3 x minus 5 if x is greater than 0. Graph the piecewise defined function. Okay, so let's do that. So it has y equaling 5x minus 1 has a y-intercept of 1 and a slope of 5, so you go over 1 up 5, and it's only defined for less than or equal to 1, 2, 3, 4, 5. So it should look something like this. Now, and that's the graph of y equaling 5x minus 1. Notice that it's only, actually it's almost looks like it's not touching. Nice, it's not going through there. So let's see there. Okay, that looks a little bit better. So this is the graph of y equaling 5x minus 1. Notice that I erased sort of the rest of the graph because it's only true if x is less than or equal to 0. If x is greater than 0, well, it's here at negative 5. 1, 2, 3, 4, 5. It has a y-intercept and has a slope of 1/3. So you go over 3 up 1. Okay, and so that is the graph of this piecewise function. So for x less than or equal to 0, it looks like this line. For x greater than 0, it looks like this line. Since this has an equal sign, I include this point, the y-intercept. Since this does not have a equal sign, I do not include this y-intercept. Let me do problem number 25. So f of x is equal to 2x minus 1 if x is less than or equal to 1 and negative x if x is greater than 1. Okay, so let's graph this. So it looks like when x is 1, if I plug 1 to here, 2 minus 1 is 1. And this has a slope of 2, so you go over 1 up 2. So it should look like this. I include the value when x is 1 because I include because that says 1. Now, if x is greater than 1, then it looks like the graph of negative x. So at 1, it's negative 1. And it looks like that. Okay, so this is the graph of y equaling f of x. So it has a slope of 2 for x less than 1 and a slope of negative 1 for x greater than 1. Let me do problem number 26. Oh, it's another piecewise defined function. F of x is equal to 26. Negative x plus 2 if x is less than 0, and 3x minus 4 if x is greater than or equal to 0. Okay, so let's sketch a graph of this. So at 0, I have that the first negative x plus 2 has a y-intercept of 2, but I don't include it because this is only true for x's being less than 0. It has a slope of negative 1, so run of 1 and a rise of negative 1. And so it looks like that for x less than 0 has a slope of negative 1. And for x greater than or equal to 0, well, it has a y-intercept of negative 4. So I include the negative 4. And it has a slope of 3. So it goes over 1 up 3. So it should look something like this. It's not steep enough. Okay, so it goes through right there. And that is the graph of y equaling f of x. So for x greater than 0, it has a slope 3, less than 0, a slope of negative 1. Let me do problem number 27. Solve the system. X plus y plus z equals 2. Let me call that R1. R2, x minus y plus 4z equals 2. And the third equation, 2x plus y plus z equals negative 1. Okay, so let me add the first. So let me eliminate y. So let us use the first, second, and third equation to find two equations where I've eliminated y. So let's just add R1 plus R2. So I have x plus y plus z equals 2. X minus y plus 4z equals 2. Add these. So I get 2x plus 5z equaling 4. Let me call that my first equation, S1. Next, let's do, let's say R2 plus R3, x minus y plus 4z equaling 2, R3, 2x plus y plus z equaling negative 1. And let's add these together. So I get 3x plus 5z equals 1. Let me call that S2. And let's eliminate Z. So let me subtract from that S1. Minus 2x minus 5z equaling negative 4. And so let's do that. So I get 3x minus 2x is x. The z's cancel. Equals negative 3. Good. Now, let's figure out what x is, what z is, let's say. So let's use S2. I have 3x plus 5z equals 1. So a negative 9 plus 5z is 1. Add 9 to both sides of my equation. So I get that 5z equals 10. Divide by 5. So z equals 2. Good. And lastly, let's plug into, let's say, R1. X plus y plus z equals 1. No, it's not. It's equal to 2. So R1 x plus y plus z is 2. Okay. And so y minus 1 is 2. Add 1 to both sides of your equation. So z is 3. So y is 3. Therefore, my solution is x, negative 3, y, 3, z, 2. And that is my solution to this system of equations. Okay, good. That's the way they wrote it. Let me do problem number 28. So my first equation, x minus y plus 5z equals negative 28. Second equation, 3x plus z equals negative 5. Third equation, x plus 2y plus z equals 1. Okay, so let's eliminate y. So R2 is already, I've already eliminated y. So that's good. So I just have to do R1 to R1 plus R3. So x plus 2y plus z equals 1. 2x minus 2y plus 10z equals negative 56. Let's add. So I get 3x, y's cancel, plus 11z equals negative 55. Call that, I don't know, S1. I also have R2, so let's subtract R2 from it. Negative 3x minus z equals 5. Okay. 11z minus z is 10z. 5 minus 55 is negative 50. Divide both sides of the equation by 10. So z equals negative 5. Let me solve here for x. So let's plug into R2. So I have 3x plus negative 5 equals negative 5. Yes. So let's add 5 to both sides of my equation. So 3x is equal to 0. Divide both sides of your equation by 3. So x is equal to 0. And lastly, let's figure out y. I guess I'll do equation 3, x plus 2y. So x plus 2y plus z equals 1. Okay. So x plus 2y plus z equals 1. And so I have that. Let's add 5 to both sides of your equation. So I have that 2y is equal to 6. Divide both sides of your equation by 2. So y equals 3. So my solution is x is 0. Y is 3, and z is negative 5. And that is the solution to my system. Next, let me do problem number 29. X plus 3y minus z equals negative 6 minus 4x minus 12y plus 4z equals 24. Negative 5x minus 15y plus 5z equals 30. Okay, so let me use an augmented matrix notation. So 1, negative 4, negative 5, 3, negative 12, negative 15, negative 1, 4, 5, augmented with negative 6, 24, 30. Okay, so let me pivot. So this is just 1, 3, negative 1, negative 6. Okay, so let me multiply the first row by 4 and add to the second row to get a new second row. And so 4 minus 4 is 0, 12 minus 12 is 0, 4 minus 4 is 0, 24 minus 24 is 0. Let me take the third row and add to it 5 times the first row to get a new third row. 5 minus 5 is 0, 15 minus 15 is 0, 5 minus 5 is 0, 30 minus 30 is 0. And so this says that x plus 3y minus z is equal to negative 6. And that's the only equation you have left. The solution is, well, I can write everything in terms of x, in terms of y and z. And so this just says that if I subtract 3y add z, this just says that x is equal to z minus 3y minus 6. Okay, so you can write your solution parametrically as z minus 3y minus 6 y z. And this is for any y and z. Okay, so it is a plane in 3 dimensions. Let me do problem number 30. And she wrote your answer as a plane. She wrote it in the first way, not parametrically. Problem number 30, simplify. 18, x negative 1, y 4, 3x, y negative 2. Okay, so I've got a negative exponent, so let's bring that from the numerator to denominator. Interchange this from the denominator to the numerator. So this is the same as 18 y to the 4th, bring up y squared over 3x, bring down the other x. So this is equal to, well, 18 divided by 3 is 6. Y to the 4th times y to the 2nd is y to the 6th. X times x is x squared. And that is your answer. Simplify, write the answer with positive exponents. I forgot to read that to you. 31. 22 x to the 5, 8x to the negative 3. So let me bring the x cubed up to the numerator. So this is equal to 22x times x to the 5th times x to the 3rd over 8. I can divide both 22 and 8 by 2. I don't need that much space. I have the same base x. Let me add exponents. 1 plus 5 plus 3 is 9. So 11x to the 9 over 4. Let me do problem number 32. X, y to the 4, x cubed, y, then negative 2. Okay, so this is equal to, let's raise everything to the power negative 2. So x to the negative 2. 4 times negative 2 is negative 8. 3 times negative 2 is negative 6. And 1 times negative 2 is negative 2. Let's bring everything that has negative exponent, bring it down to the denominator. Everything that has a negative exponent, let's interchange. So let's bring this guy up and this guy up. And so everything just interchanges. So you get x to the 6, y squared from the denominator, x squared y to the 8th for the numerator. 6 is greater than 2, so I have the same base x here. 6 is greater than 2, so x will stay in the numerator. 6 minus 2 is 4. I have the same base y. 8 is greater than 2, so y will stay in the denominator. 8 minus 2 is 6. And that is your answer. Of course, there's a wide variety of differing ways you couldn't got to this answer. And several of which have all the same difficulties, same level of difficulty. So 33, 4x negative 2 y 2 over 12x negative 4 y negative 1 cube. Well, let me simplify what's inside the parentheses first. 12 divided by 4 is 3. If I have a negative exponent, let me interchange it from the numerator to the denominator. So the x squared comes down, the x to the fourth goes up, the y to the first goes up, and the y squared remains. So I'll bring down this x, but bring up the x's and y's. And so I get 4 divided by, so x, let me keep simplifying. What's in the numerator? I have the same base x. 4 is greater than 2, so x will stay in the numerator. 4 minus 2 is 2. I have the same base y, I'm multiplying. And so I'll add exponents. 1 plus 2 is 3. Let's raise each of these to the power 2. To the power 3, sorry. And so 2 times 3 is 6. 3 times 3 is 9. 3 cubed is 27. And that is your answer. Okay. Let me do problem number 34. Five x y cubed z negative 3 square 4x 6 y z negative 3 negative 1. Okay, so let's square everything inside the parentheses. 5 squared is 25. X squared is x squared. Y cubed squared is y to the 6. Z to the negative 3 squared. Well, negative 3 times 2 is negative 6. Let's raise everything in the denominator to the power negative 1. So I have 4 to the negative 1. 6 times negative 1 is negative 6. 1 times negative 1 is negative 1. Negative 3 times negative 1 is a positive 3. And so let's bring everything that has a negative exponent and interchange it between numerator and denominator. So the z will go down here. The 4 will go up. X will go up. Y will go up. And so the 4 goes up. The x goes up. The y goes up. The z goes down. And so I have z cubed, and the z to the 6 went down. So this is equal to 4 times 25, 100. I have the same base x. I'm multiplying 2 x squared times x to the 6. So you add exponents. 2 plus 6 is 8. I have the same base y. I'm multiplying, so I add exponents. 6 plus 1 is 7 over z. I'm again multiplying. I have the same base z, so I add exponents. 3 plus 6 is 9. And that is your answer. Okay. Let me do problem number 34. I'm sorry. Problem number 35. Four y negative 5 x to the fifth cube 16 x to the negative 5 y to the negative 4 to the negative 1. Okay, so let's raise each of these to the power. So 4 cubed, negative 5 times 3, negative 15. 5 times 3, 15. Raise each of these to the power negative 1. Negative 5 times negative 1 is 5. Negative 4 times negative 1 is a positive 4. Let me bring the negative exponent down. Bring the negative exponent down. So you get 64 over x to the 15, y to the 15, times the 16 goes down, the x to the fifth and y to the fourth remain in the same location. 64 divided by 16 is 4. I have the same base x. 15 is greater than 5, so I keep x in the denominator. 15 minus 5 is 10. I have the same base y, and they're being multiplied. So I add exponents. 15 plus 4 is 19. And that is your answer. Let me do problem number 36. X cubed minus 8 minus x equals negative 8x squared plus 8. Solve the equation. Okay, so let's solve this. First, let's bring everything to one side of the equation. So let's set the right-hand side of the equation to 0. Add 8x squared, subtract 8 from both sides of my equation. So I get x cubed plus 8x squared minus 8x minus 8 is 0. Let me factor by grouping. Group the first two terms. The last two terms, please note, since I have a negative outside the parentheses, I have to change all the signs inside the parentheses. So the negative x becomes a positive x. The negative 8 becomes a positive 8. Factor out what the x squared. What remains is x plus 8. Factor out the 1. What remains is x plus 8. And so I have a x plus 8 in common. I can, after I factor out the x plus 8, I have an x squared minus 1 remaining. Factor, well, this is just by the special product formula. The difference of squares is just the product of the sum and difference of their terms. And so, by the zero factor property, I can set each factor to 0 and solve for x. Subtract 8, add 1, subtract 1. So x is equal to negative 8, positive 1, -1. So this cubic equation has three solutions: -1, +1, -1. So I'm sorry, -8, +1, -1. Let me do problem number 37. X plus 5, x minus 3, x minus 20 equals 0. So let's, by the zero factor property, let me set each of these to 0 and solve for x. So x plus 5 is 0, x minus 3 is 0, x minus 20 is 0. And so I have, solving for x, x is 5, x is 3, x is 20. And that is my solution. 38. X cubed plus 3x squared is equal to 10x. Subtract 10x from both sides of my equation. So x cubed plus 3x squared minus 10x is 0. Let me factor out an x. So what remains is x squared plus 3x minus 10 equals 0. What's inside the parentheses is a monic quadrat in trinomial in terms of x. So I can put x's here. Let me drop down the plus times minus is minus. I want two whole numbers whose product is 10 and whose difference is 3. Well, 5 and 2. And I put the larger absolute value of the root first. So by the zero factor property, I set each factor to 0 and solve for x. And so I have x is 0, x is -5, x is +2. Let me do problem number 39. For this cubic, I have three solutions. So let me do problem number 39. Perform the indicated operations. Simplify if possible. So x over x plus 11 minus x over x minus 11 divide by x over 7x plus 77. Okay, so first let me change division into multiplication by the reciprocal. And so let me get a common denominator. The common denominator is x plus 11 times x minus 11. So x plus 11 times x minus 11. And so I get the following. Let me write it with that bracket. And maybe I'll put a plus there, so it'll look a little nicer. So let me multiply the x inside the parentheses the negative x inside the parentheses. So I'll get x squared minus 11x. I'll get a negative x squared minus 11x. Let me factor out the 7. Oops. Let me factor out the 7. So this is equal to well, the x squares cancel. You get a negative 22x over x plus 11, x minus 11, times 7x plus 11 over x. The x's cancel. The x plus 11's cancel. So you have a negative 22 times 7, which is a negative 154, over x minus 11. So the x's cancel, and the x plus 11's cancel. Okay. The 40. 5 over x, 2 over x plus 2 minus 2 over x minus 2. Okay, so I guess I have to simplify what's inside the parentheses. So let me get a common denominator. The common denominator is x plus 2 times x minus 2. And so I get 5 over x. I get a 2x, multiplying the 2 inside the parentheses, minus 4. Multiply the negative 2 inside the parentheses. So I get negative 2x minus 4. So this is equal to 5 over x. The 2x's cancel. Minus 4 is a negative 8 over x plus 2, x minus 2. Positive times negative is negative. So we get a negative 40 over x plus 2, x minus 2. And that is your answer. Any questions about that? Good. Okay, let me do problem number 41. Solve the equation 1 over x plus 4 minus 7 over x minus 4 equals 4 over x squared minus 16. Okay, so first off, let me factor the x squared minus 16. Again, it's just the difference of squares. So you have the product of the sum and difference of two terms. Let's multiply both sides of my equation by the least common denominator, x plus 4, x minus 4. So the x plus 4's cancel, so you just get x minus 4. The x plus 4's cancel, so you just get a negative 7 times x plus 4. The x minus 4's and the x plus 4's cancel, equals 4. Let me multiply the negative 7 inside the parentheses. So I get x minus 4 minus 7x minus 28 is equal to 4. Combine like terms, negative 6x minus 32 equals 4. Add 32 to both sides of my equation. So negative 6x is equal to 36. Divide both sides of my equation by negative 6. So x is equal to negative 6. Since I'm not dividing by 0 when x is negative 6, negative 6 plus 4 is not 0, negative 6 minus 4 is not 0, negative 6 squared minus 16 is not 0, then x equaling negative 6 is a solution. Is this question 42? Oh, let's check. You stupid jerk. Yes, it is. Yes, yes, it is. Okay, I'm sorry, that's problem number 42. So I skipped 41. Let me do problem 41 for you. Sorry about that. But that is the answer to 42 at least. Let's do problem 41. Okay, sorry about that. Let me do problem 41. 11 over x plus 11 times 7 over x plus 2 over x minus 5. Okay, that's problem number 41. Okay, so let me do that. So this is equal to 11 over x plus 11. She likes 11s. Okay, so let's get a common denominator so I can add these. So let me multiply and divide by x minus 5. Multiply and divide by x. So this is equal to 11 over x plus 11 times 7x minus 35 over x minus 5 plus 2x over x minus 5. This is equal to 11 over x plus 11. 7x plus 2x is 9x. Minus 35 over x minus 5. So this is equal to, oh, who knows how she wants to write it. Let me just check. I'm going to cheat and check to see how she wrote this. Is what, problem 41? 41. Oh, she didn't multiply it out. So it's just equal to 11 times 9x minus 35 over x plus 11, x minus 5. And that is your answer. Okay, so then I can go to 43. Okay. So problem 43. 1 x plus 5, x plus 7 plus 4 over x plus 5 equals negative 2 over x squared plus 12x plus 35. Okay, good. And so let me factor. So 1 over x plus 7 plus 4 over x plus 5 equals negative 2 over. So I can factor this. Well, this just factors into x plus 7 times x plus 5. Let me get rid of the denominators. So let me multiply both sides of my equation by the least common denominator, x plus 7 times x plus 5. So this is equal to, well, the x plus 7's cancel. So you just get, oops. So you just get 1 times x plus 5. The x plus 5's cancel, so you just get 4 times x plus 7. The x plus 7's and the x plus 5's cancel, equals negative 2. Let me multiply the 4 inside the parentheses. So by distributive property, we have x plus 5 plus 4x plus 28 equals negative 2. Combining like terms, I have 5x plus 33 is negative 2. Subtract 33 from both sides of your equation. So 5x equals negative 35. Divide by 5. So x equals negative 7. But when x is negative 7, if you look in the original problem, I'm dividing by 0. So that's a contradiction. So this is not a solution. So in this case, it means that there is no solution to this equation. The only possible solution was an extraneous solution. So there's no solution to this particular problem. Let me do problem number 44. Six over 5x minus 1 over x plus 1 equals 1 over 3x squared plus 3x. Okay. So let me factor. I can factor out a 3x, where it remains as x plus 1. So let me multiply both sides of my equation by least common denominator. 3 times 5 is 15x, x plus 1. And so that's the least common denominator. You can multiply by any common denominator, but this is the least one. And so the 15x, so I have 6. 15x divided by 5x is 3. And I still have an x plus 1 remaining. Minus, the x plus 1's cancel, so you have a 15x. 15x divided by 3x is 5. The x plus 1's cancel. Let me multiply the 18 inside the parentheses. So I get 18x plus 18 minus 15x is 5. And so 18x minus 15x, 3x plus 18 equals 5. Subtract 18 from both sides of my equation. And so 3x is equal to negative 13. divide both sides of your equation by 3. And so I have that x equals a negative 13 over 3. Well, when x is negative 13 over 3, I'm not dividing by 0. And so that's your answer. Then we do problem number 45. $40 over 25 minus x squared plus 5 over 5 plus x equals 4 over 5 minus x. So let's factor. It's the difference of squares. So by the special product formula, 5 minus x, 5 plus x. 5 over 5 plus x, 4 over 5 minus x. Let me multiply both sides of my equation by 5 minus x, 5 plus x. So the 5 minus x's cancel, and you just get 40 times, the 5 minus x's cancel, the 5 plus x's cancels. You just get 40 plus the 5 plus x's cancel, so you just get 5 times 5 minus x. The 5 minus x's cancel, so you just get 40 times 5 plus x. Use the distributive property to multiply each of these constants inside the parentheses. So 40 plus 5 times 5, 25. 5 times minus x minus 5x. 4 times 5, 20. 4 times x, 4x. Combine like terms. 40 plus 25, 65. Subtract 20. Add 5x to both sides of your equation. And so you get that 45 is equal to 9x. Divide by 9. So you get x is equal to 5. But if you plug 5 in, notice that you're dividing by 0 here. So 5 is not a solution. Therefore, this equation has no solution. Okay, let me do problem number 46. A boat moves 10 kilometers upstream. So you have some boat. There, boat. And it moves 10 kilometers upstream in the same amount of time as it moves 15 kilometers downstream. Okay. If the rate of the current is 7 kilometers per hour, find the rate of the boat in still water. So let's say R kilometers per hour in still water. And we have that these are equal time. So same time to go upstream and downstream. Okay, so I have distance equals rate times time, or time is distance over rate. Okay, so let's do that. So let's figure out the time. Well, the time for this boat to go upstream is the distance. Well, the distance is 10 over the rate. Oh, let's call it x then, because I'm calling that r. And so the rate is, well, if it's going upstream, then it's fighting against the current. So it normally goes x kilometers per hour, but there's just a current of 7 kilometers per hour, so it has to go against that current. This is the same time it takes to go downstream. He goes 15 kilometers downstream, and he is helped by the current, so his speed is actually faster. He normally goes x kilometers per hour, but since the current is pushing him along, he goes x plus 7 kilometers per hour. Let's cross multiply. So I get 10x plus 70 is equal to 15x minus 105. Subtract 10x, add 105 to both sides of the equation. So 175 is equal to 5x. Divide both sides of your equation by 5. And so I get that x is equal to 35. And so in still water, the boat normally goes 35 kilometers per hour. Let me do problem number 47. Jim can run 5 miles per hour on level ground on a still day. Okay. So you have someone can run 5 miles per hour. So 5 miles per hour. Okay. This is on a still day. On a windy day, he runs 12 miles with the wind. So here's the wind. So he goes 12 miles going this way. In the same amount of time, maybe I'll put him over the wind so you can see it. So he's able to go 12 miles in the same amount of time that he runs 4 miles against the wind. He's going against this wind. Okay. So these will be the same time. What is the rate of the wind? So let's say the wind is x miles per hour. And that's what I want to figure out. Okay, so distance equals rate times time. So that says that rate time, I want to figure out the same time, so time equals distance over rate. And so let's figure out how long it takes him when he's going with the wind. And so he travels 12 miles. His rate is 5 miles per hour, but he's being helped by a wind that pushes him along at an additional X miles per hour. Next, let's figure out the time when he goes against the wind. Well, he goes 4 miles. Normally he goes 5 miles per hour, but the wind is pushing him back at X miles per hour. So he's only going 5 minus X miles per hour. Cross multiply. Solve for X. So 60 minus 12X is equal to 20 plus 4X. Cross multiplying. Add 12X. Subtract 20 from both sides of your equation. And so 40 is equal to 16X. So divide both sides of your equation by 16. So X is equal to, I can divide both 40 and 16 by 8. So 5 over 2. Maybe I'll write it actually as 2.5 miles per hour. So rather than, you would normally not say your rate that you're going as a fraction. So I'll just write it as 2.5 miles per hour. And that's the rate of the wind. Okay. Let me do problem number 48. Use the properties of exponents to simplify the expression. Okay, so let's do that. So problem number 48. R to the 1/9 S to the 1/9 squared. So this is equal to 2 times 1/9 is 2/9. 2 times 1/9 is 2/9. And that is your answer. Let's do problem number 49. Y to the 5 over 9. Y 3 over 9. 6. Y 2 over 9. So let me multiply the y to the 5 over 9 inside the parentheses. So you get y to the 5 plus 3 is 8 over 9 minus 6. 5 over 9 times 2 over 9. Well, 5 plus 2 is 7 over 9. And that is your answer. 50. Negative 4 p to the 3/5 plus 6 p to the 4/5 minus 4 p to the 3/5 plus 6 p to the 4/5. Oh. Negative 4 times negative 4 is a positive 16. 2 times 3/5 is 6/5. 4 times negative 4 times 6 is 24 times 2 is 48. P to the 3/5 times p to the 4/5. Well, 3 plus 4 is 7/5. 6 times 6 is 36. P to the 4/5 times p to the 4/5. Well, 4 plus 4 is 8/5. And that is your answer. 51. X to the 4/3, x to the 6/5 over x negative 1/2. Okay, so let's multiply these together. Now notice that since I have a negative exponent, I'll bring it up to the numerator. Oops. In order to add these, I need a common denominator, 30. So multiply by and divide by 10, 6, 15. And so I have x to the 40 over 6, 36 over 6, 15 over 6. Why did I? Okay. 30, 30, 30. Sorry about that. And so I'm multiplying. Since I have the same base x, let's add exponents. 40 plus 36 plus 15, 91 all over 30. And that is your answer. Let me just check. 76, 86, 91. Okay, good. 52. 10 rad 17 plus 4. Rationalize the denominator. Assume all variables represent positive real numbers. Okay, so let me multiply and divide by the conjugate of the denominator. Rad 17 minus 4. So this is equal to 10 times rad 17 minus 10 times 4, 40. Again, this is the product of the sum and difference of two terms, so it's a difference of their squares. Rad 17 times rad 17 is 17. 4 times 4 is 16. Well, 17 minus 16 is just 1. So this is just equal to 10 rad 17 minus 40. Let me do problem 53. 6 minus rad 7. No, rad 6 minus rad 7 over rad 6 plus rad 7. Okay, so let's rationalize the denominator. So let me multiply and divide by the conjugate of the denominator. Rad 6 plus rad 6 minus rad 7 over rad 6 minus rad 7. Okay, so this is equal to Rad 6 times rad 6 is 6 minus rad 6 times rad 7 is rad 42, and there are two of them. Rad 7 times rad 7 is 7. This is the product of the sum and difference of two terms, so the difference of their squares. Rad 6 times rad 6 is 6. Rad 7 times rad 7 is 7. 6 plus 7 is 13. Six minus 7 is a negative 1. And so this is just equal to dividing each of these by negative 1, 2 rad 42 minus 13. Just changing each of the signs. Let me do problem 54. Six rad 5 plus rad 10. 6 rad 5 minus rad 10. So let me multiply and divide by 6 rad 5 plus rad 10. 6 rad 5 plus rad 10. So this is equal to 6 times 6, 36. Rad 5 times rad 5, 5. 6 rad 5 times rad 10 is rad 50. 6 plus 6 is 12. Rad 10 times rad 10 is 10. Again, the denominator is the product of the sum and difference of two terms with difference of their squares. 6 times 6 is 36. Rad 5 times rad 5 is 5. Rad 10 times rad 10 is 10. 36 times 5 is 180 plus 12. That's right, 50 is 25 times 2. Again, 36 times 5 is 180 minus 10. And so 180 plus 10 is 190. The square root of 5, square root of 25 is 5. 180 minus 10 is 170. And so I get 190 plus 12 times 5, 60, rad 2, all over 170. I can factor out a 10 from each of these. So this is 10 times 19 plus 6 rad 2 over 170. So I can divide both numerator and denominator by 10. And so I get 19 plus 6 rad 2 all over 17. And that is your answer. Let me do problem number 55. Rad x plus 4 minus 5 equals 0. Solve. Okay, so let's solve this radical equation. So let's add 5. So I get rad x plus 4 is equal to 5. Isolating my radical on one side of my equation. So now I can square both sides of my equation to get rid of the radical. And so the square gets rid of the square root. 5 squared is 25. Subtract 4. So x is equal to 21. Well, let's check to see that this is not an extraneous solution. So I have, is the square root of 21 plus 4 minus 5 equal to 0? Well, is the square root of 25 minus 5 0? Yes. So yes, x is 21. Let me do problem number 56. Square root 2x plus 9 minus 2 equals 0. And so let's add 2 to both sides of your equation. So I have the square root of 2x plus 9 is equal to 2. Let me square both sides of my equation. And so the square gets rid of the square root. 2 squared is 4. Subtract 9 from both sides of my equation. So 2x is equal to negative 5. Divide by 2. So x is equal to negative 5 halves. Let's check. So is the square root of 2 times negative 5 halves plus 9 minus 2 equal to 0? Is the square root of, the 2's cancel, negative 5 plus 9 minus 2, is that equal to 0? Is the square root of 4 minus 2 0? Yes. And so x is equal to a negative 5 over 2. 57. Cube root x plus 5 plus 2 is equal to 0. Subtract 2 from both sides of your equation. So I get the square root of x plus 5 equals negative 2. Cube both sides of your equation. And so x plus 5 is equal to negative 8. Subtract 5. So x is negative 13. And if I've done my algebra correct, then that should be the correct answer. I don't need to check. Do 58. Cube root 3x plus 2 minus 4 equals 0. Add 4. So cube root 3x plus 2 is equal to 4. Cube both sides of your equation. And so 3x plus 2 is equal to 4 cubed, which is 64. Subtract 2. And so 3x is equal to 62. Divide by 3. So x is equal to 62 over 3. And again, it's a cube, so I don't have to check. Let me do problem number 59. Perform the indicated operations. Write the result in the form a plus bi. So 5 plus 9i, 5 plus 8i. So let's rationalize the denominator. So let me multiply and divide by 5, the conjugate of the denominator, complex conjugate. 5 minus 8i. And so I get 25 minus 40i plus 45i minus 72i squared. Well, in the denominator, this is the product of the sum and difference of two terms. And so it's just the difference of their squares. 5 squared, 25. 8 squared, 64. I squared, well, I squared. But remember that I squared is negative 1. And so this becomes 25. 45i minus 40i is 5i. The negative 72i squared becomes a positive 72. The negative 64i squared becomes a positive 64. So, combining like terms, you get 97 plus 5i over 89. And since you want to write it in standard form, I'll write it as 97 over 89 plus 5 over 89i. 89. And that is your answer. Let me do problem number 60. Eight minus 5i, 8 plus 2i. So let me multiply and divide by the conjugate of the denominator. 8 minus 2i. And so let's multiply this out. So I get 8 times 8, 64. There it is. 8 times minus 2i, minus 16i. Negative 5i times 8, negative 40i. Negative 5i times negative 2i, 10i squared. Over, well again, 64 minus 4i squared. It's a difference of squares. Again, recall that I squared is negative 1. So this is equal to 64 minus 16i minus 40i is a minus 56i. Combine like terms. The plus I squared becomes the plus 10i squared becomes a minus 10. The minus 4i squared becomes a plus 4. And so this is equal to 64 minus 10, 54, minus 56i. 64 plus 4, 68. Let me factor out a 2, so I get 27 minus 28i over 68. Let's divide both numerator and denominator by 2. So I get 27 minus 28i over 34. Oh, and we want to write it this way as 27 over 34 minus 28 over 34i. So that means I can reduce it further. This is 27 over 34 minus, I can divide 34 and 28 by 2, so that's 14 over 17i. And that is your answer. Let me do problem number 61. Hmm. 6 minus 6i over negative 2i. In this case, let me just multiply by negative I. I'm not actually doing the conjugate or anything, but this will still give you a nice, easy answer. So this is equal to a minus 6i. Minus and minus gives it plus 6i squared over plus, well, actually, let me multiply by just positive I, because that'll be a nicer way. Give me a nicer answer. Okay. And so this is equal to 6i, oops, 6i minus 6i squared over a negative 2i squared. But again, I squared is negative 1. So this is equal to 6i plus 6i plus 6. Negative 6i squared becomes a plus 6 all over 2. Since a negative 2i squared becomes a positive 2. And so this is just equal to, well, 6 divided by 2 plus 6 divided by 2i, which cancels everything to become 3 plus 3i. And that's your answer. 62. So problem number 62. Oh, wow. We're at the halfway point. Okay, 62. 4 plus 9i. 4 minus 9i. So let me multiply and divide by the conjugate of the denominator. 4 plus 9i. And so I get, by the special product formula, 4 times 4 squared is 16. 4 times 9 is 36. Times 2 is 72i. 9i times 9i squared gives you a 81i squared over 4 squared is 16. 81 I squared. I squared is negative 1. So you get 16 plus 72i minus 81 over 16 plus 81. And so 16 minus 81, a negative 65, plus 72i over 16 plus 81, 97. So I can write this as negative 65 over 97 plus 72 over 97i. And that is your answer, 63. Solve. X to the 4 minus 20x squared minus 125, 0. Well, this is a monic quadratic in x squared trinomial. So I can factor this as x squared, dropped on the minus, times minus is plus. I want two whole numbers whose product is 125 and whose difference is 20. So 25 and 5. I can factor. X squared minus 25 is just the special product formula. X minus 5, x plus 5. I can't factor the sum of squares, and so over the reals. So by the zero factor property, I set each factor to 0 and solve for x. So adding 5, subtracting 5, subtracting 5, I get x is equal to 5, x is equal to negative 5, and well, since x is equal to, since x squared equals negative 5, then x is equal to plus or minus the square root of negative 5, which is equal to plus or minus I rad 5. Okay. Didn't say you only wanted reals. Let me check, but I'm sure 63, unless she had a typo. Yep, no, she wanted all of them. Okay. 64. X to the 4 minus 5x squared plus 4 is 0. Again, this is a monic quadratic trinomial in x squared. So I can factor this as x squared. Bring down the minus, times plus is minus. I want two whole numbers whose product is 4 and whose sum is 5. So 4 and 1. I can factor difference of squares, x minus 2, x plus 2. I can factor difference of squares, x minus 1, x plus 1. Why did I write plus 1? I have no idea. Okay, so x minus 2, x plus 2. Set each factor to 0 and solve for x. So by the zero factor property, we just set each of these to 0 and solve for x. Add 2, x is 2. Subtract 2, x is negative 2. Add 1, x is positive 1. Subtract 1, x is negative 1. Okay, so that's 64. And we do 65. So notice you have 4 solutions for a fourth degree equation. 65. X squared, no. X to the 4 plus 11x squared minus 900 equals 0. And so let me factor this. Again, this is a monic quadratic trinomial in x squared. So bring down the plus times minus is minus. I want two whole numbers whose product is 900 and whose difference is 11, 36 and 25. Yes. And so uh, 36 times 25 is 900. 36 minus 25 is 11. Let's factor these. So this factors into x plus 6i, x minus 6i, x minus 5, x plus 5 equals 0. Let's go with the same sign. It's a difference of squares formula for each of these. And set each factor to 0 and solve for x. Adding 6i to both sides of your equation, x equals 6i. Subtracting 6i from both sides of your equation, x equals negative 6i. Adding 5 to both sides of your equation, x equals positive 5. Subtracting 5 from both sides of your equation, x equals negative 5. Let's do problem number 66. X plus 1, x minus 1 is less than or equal to 0. Solve the inequality, graph the solution set, and write the solution set in interval notation. Okay, so let's first, it's already in standard form, factor standard form. So let's determine the critical numbers. And so set x plus 1 to 0, x minus 1 to 0, subtract 1, add 1. So x equals negative 1, x equals positive 1. Place these on my number line. Place these critical numbers on my number line. If x is between negative 1 and 1, let's take 0. So 0 plus 1 is positive, 0 minus 1 is negative. Positive and negative is negative. Since each of the roots, each of the critical numbers are simple roots, they all have odd multiplicity of 1, then these alternate. So plus minus plus. We want this to be less than 0, so you fill in where it's less than 0, where it's negative. And you have that it's strictly less than 0. So you do, oh no, it's less than or equal to. There's an equal there. So you fill in each of the critical numbers. The only time you don't fill in a critical number when you have an equal sign is if the expression is not defined at that particular critical number. And so the answer is the closed interval from negative 1 to positive 1. Okay, 67. Oh, let me read the, write the solution set in interval notation and graph it. Yep, so I did that. 67. X plus 6, x plus 4, greater than 0. So again, it's already in factored standard form. So let's determine my critical numbers. So let's set each of the factors to 0 and solve for x. So x is negative 6, X is negative 4. Let me place those on my number line. And so, let me take a number greater than negative 4. Let's say 0. At 0, I have positive times positive is positive. Again, each of the critical numbers are are simple roots. They all have multiplicity of 1. And so the signs alternate. So plus, minus, plus. I want this to be greater than 0. So I fill in the pluses. And I want it to be greater than 0. So I do not fill in the critical numbers. And so we have the union of two open intervals from negative infinity to negative 6, negative 4 to positive infinity. And that is your solution set. 68. X squared minus 4x plus 3 greater than 0. So let's factor x minus 3, x minus 1. Again, this is a monic quadratic trinomial in x. So I'll put x's here. Bring down the minus times plus is minus. I want two whole numbers whose product is 3 and whose sum is 4, 3 and 1. So this is in factored standard form. So let me determine my critical numbers. So let's set each factor to 0 and solve for x. Add 3, add 1. Place these critical numbers on my number line. Take a number less than 1, let's say 0. At 0, it's going to be positive. Again, each of the roots are simple roots, and therefore they have multiplicity of 1 and odd multiplicity. So the signs alternate. We want this to be greater than 0, and so I fill in where it says greater than 0. And I don't include the critical numbers because there's no equal sign. And so this is the union of two open intervals, negative infinity to 1, 3 to infinity. And that is your answer. Let me do 69. X squared plus 4x less than negative 3. Add 3 to both sides of your inequality. So x squared plus 4x plus 3 less than or equal to 0. Again, this is a monic quadratic trinomial in x. So I can drop down the plus times plus is plus. I want two whole numbers whose product is 3 and whose sum is 4, 3 and 1. So this is now in factored standard form. So let me determine my critical numbers. So let me set each factor equal to 0 and solve for x. Subtract 3 from both sides. Subtract 1 from both sides. Place these on my number line. Take a number greater than negative 1, let's say 0. So this is going to be positive. And so, um, since each of the roots, each of the critical numbers, are simple roots, they have multiplicity 1, which is odd multiplicity, so everything alternates. So plus, minus, plus. We want this to be less than 0, so I fill in where it's negative. And I want this to be less than or equal to 0, so I fill in each of these critical numbers also. And so this is just the closed interval from -3 to -1. And that's your answer. Let me do 70. X plus 6, x plus 3, x minus 1, greater than 0. This is in factored standard form, so I can determine the critical number. So now let us determine the critical numbers. Set each factor equal to 0 and solve for x. And so subtract 6, x is -6. Subtract 3, x is -3. Add 1, x is +1. Let me place those critical numbers on the number line. -6, -3, +1. Take a number between -3 and 1. Let's say 0. Positive, positive, negative gives me a negative. All the roots, all the critical numbers are simple roots. They all have multiplicity 1. They all have odd multiplicity, so everything alternates. All the signs alternate for these regions. We want it to be greater than 0, so I fill in the plus. I want this to be strictly greater than 0, so I don't fill in the critical numbers. So I'll leave those critical numbers open. So in this case, it's the union of two open intervals. -6 to -3, union the interval from 1 to positive infinity. Okay. Let me do problem number 71. $114. Okay. Let me do problem number 71. A rocket is launched from the top of a cliff that is 112 feet high with an initial velocity of 336 feet per second. The height h of t of the rocket after t seconds is given by the equation h of t equals -16 t squared plus 336 t plus 112. Okay, so you have some rocket and it is launched off of this cliff. Okay, and I want to figure out how long after the rocket is launched will it take to strike the ground. So that's what I want to determine. Okay, so strike the ground, round to the nearest tenth of a second if necessary. Okay. So let me solve this. So it strikes the ground when it is 0 feet above the ground. So I have here negative 16t squared plus 336t plus 112 is 0. I can factor out a negative 16. So this is just t squared. 336 divided by 16 is 21. 112 divided by 16 is 7. Yes, 7. Okay. Oh, so you can't factor that. So I guess the only thing to do is notice I can divide both sides of my equation by negative 16. So I just get t squared minus 21t minus 7 is 0. So let's use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, of course, our variable is an x. It's t, so I wrote down t. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so I have that t is equal to 21 plus or minus the square root of a negative 21 squared, 441, minus 4 times 1 times minus 7 is a positive 28 all over 2. And so I have here 21 plus or minus the square root of 441 plus 28, 469 over 2. Now, the square root of 469, well, it's going to be bigger than 21. Therefore, if you subtracted 21 minus that larger number, you're going to get a negative number. And I don't want a negative time. So t is just equal to 21 plus the square root of 469 over 2. Here, however, they told you that they want you to approximate the answer. And so let's plug that into my calculator. So it's 21 plus the square root of 469. Divide that by 2. It is 21.32820391, and they tell us to round to the nearest tenth of a second. Okay, nearest tenth. So t is approximately 21.4 seconds. Rounding to the nearest tenth of a second. Let me do problem number 72. An arrow is fired straight. So arrow is fired straight up into the air. An arrow is fired straight up into the air with initial velocity of 128 feet per second. The height in feet of the arrow t seconds after it is shot in the air is given by the function. So its height here is negative 16t squared plus 128t. Find the maximum height of the arrow. Well, I know by the formula for completing the square, that the vertex of this parabola, which is the highest point here, is found by, well, the x-coordinate was x equal negative b over 2a. Again, we're using t, so t equal negative b over 2a. So b in this case is 128. A in this case is negative 16. Negative and negative become a positive, 128 over 32. But 128 over 32, that's just 4. And so now, that's the amount of time it takes for it to hit the ground. So now let's figure out what the actual height is. So let's plug in for h, 4. So negative 16 times 4 squared plus 128 times 4. So let's figure out this height. And so 4 times 4 is 16. 4 times 128 it's going to be, is 512. 16 times 16 is 256. 512 minus 256 is 256. And so its maximum height is 256 feet above the ground. Okay, good. So that does problem 72. We have a total of 114 problems, which means I will not get done. Okay, so I'll ask you what do you guys want to cut it off right here and then we'll continue with it. I'll see what you guys want to do, probably Tuesday night, because you have your exam on Tuesday. So Tuesday night, do you want to do it on Tuesday night after your exam? How's that sound? Yes, no? It's been so long, people's brains are completely fried. Yeah. Okay, yeah. So I think what I'll do is I will end it at this moment because it's been